Hi, in this video we are going to implement the method that's going to get the maximum of the heap. So I'm going to have a public integer get max, and of course the result we are going to return is going to be the heap with the index 0. This is what we have been discussing, that the 0 index value is going to be the maximum item for a maximum heap, the minimum item for a minimum heap. We are implementing a maximum heap, so the 0 index is going to be the maximum item. So first we are going to return the result. But of course we have to rearrange the heap because we have taken the maximum item, so the root of that given tree-like structure. So we have to make some reconstruction. So first of all, this dot heap with the 0 index is going to be the this dot heap with the current position minus minus. Why minus minus? Because we have get rid of the root node, so we have to decrement the number of items, so basically the last index for the items. Okay, and we have to get rid of the obsolete references, so with the current position plus 1 is going to be equal to a null. So we have managed to get rid of the root node, then we swap it with the last node, so basically the last index, which is the right child of the 100, and we have to tell it to Java that it's going to be a null. So the right child after the swap operation is going to be a null. This is how we get rid of obsolete references. Okay, and of course we have to fix down, so fix down with the 0 index and the index minus 1, we are going to talk about it. What does it mean? Why? Because if the 5 is going to be the root node, it's not going to be a valid heap, because the root node is not going to be the greatest value possible. The greatest value will be 100 after we get rid of 210. So that's why we have to fix down. The fix down means that after get rid of the 210, we swap it with the last item, as you can see, and we have to check whether is it a valid heap or not. And of course we have to swap it. Okay, so let's create this method fix down. We will have the index and the integer, for example, up to. We are going to define this up to index, and if up to is smaller than 0, then the up to is going to be the current position. This is what's happening here. We initialize it to be minus 1 because we would like to make sure that the up to is going to be the current position. What's the current position? It's going to be the index of the last item in the heap. Okay, so while the index is smaller or equal than the up to, we would like to consider every single item. Okay. We calculate the index of the left child. It's going to be 2 times the index plus 1. We want to calculate the index for the right child. It's going to be 2 times the index plus 2. And we have to check that if the left child is smaller or equal to up to, we would like to make sure that we are not going to manipulate indices greater than this up to index. So if the left child is smaller than equal to up to, we define a child to swap. So we define the index of the child we would like to swap. By the way, else we just break. Okay, so if the right child is greater than the up to, then we make sure that the child to swap is going to be the left child, because we don't want to manipulate indices out of the range. We would like to manipulate indices in the range, index and up to basically. Okay, and else we would like to calculate that the child to swap is going to be the heap with the left child is greater than the heap with the right child. So basically we would like to decide what's the greater, the left child value or the right child value. If the left child is greater, so if this is true basically, then we would like to make sure that the child to swap will be the left child. Anyways, the child to swap will be the right child. Okay, and here we just have to swap them. So if the heap with the given index is smaller than the heap with the child to swap, why smaller? Because we are dealing with a maximum heap. So we just want to make sure that the child to swap is going to be greater than the actual one. And it's going to be the temp heap index. Heap index is going to be the heap child to swap, and the heap child to swap will be the temp. This is how we swap items. And else we do nothing, we just break out of the while loop. And of course we have to reinitialize the index to be equal to the child to swap, because we would like to consider further pairs of items in the given heap tree-like structure. Okay, so I guess that's all about the fix down method and the fix up method. In the next lecture we are going to talk about the heap sort process, and then we are going to test our heap data structure. Thanks for watching.